Rocky Mountain Propellers has been in business since 1982. We do have a little over 20,000 square foot facility and currently with 11 employees. The aircraft type that we actually handle around here in the Rocky Mountains is anything from the Cessna 152 as a trainer to Beech King Airs, Piper Cheyennes, Air Ambulance, Pilatus PC-12, even the Piaggio Avanti. Customers can not only ship their product into us for work, we also do local pickups. And on the occasion, we get the customer that flies in and we do the remove and install of their propellers from the aircraft and keep it stored inside while it's under our care. As far as the propeller work that we do, we work on old aircraft, new aircraft. So it's going to be current design propellers, older design propellers. The blades might be made of wood covered with fiberglass. They could be Kevlar covered with stainless leading edges. We also have a composite blade that's a foam core with a carbon spar.
Customer brought in this Beechcraft airplane for an overhaul. Once I get the spinner off, I'm going to take a look at the cylinder and the hub sockets and make sure that there's no obvious oil leakage. Right now I'm removing the mounting bolts from the prop so we can remove the prop from the airplane. And now we're ready to take the propeller off.
On average, propeller work is probably in the neighborhood of about 30 a month. So now we've got the prop off the aircraft, we'll bring it in, we'll place it on the vertical stand, start taking it apart, remove the blades, get everything disassembled, and then we'll take all the parts over to the solvent tank and get them washed up so we don't have any more grease and oil traveling with us while we do the rest of the process. So now all of our parts are cleaned up and we're going to bring our blades and hub into the blasting room. We have quite a few different pieces of equipment. We have two that are plastic media for stripping paint and epoxies and glues and things like that. With the blade here, we need to get all the glue off, the paint, get this totally stripped down to basically aluminum, and we're going to do that in the plastic media cabinet. The next step in the process, after we've got the paint, glue, epoxy, everything stripped from the hubs and or the blades, we'll bring them over to our etch line and put them in the basket, start to clear down at the end. It's really kind of a strong oven cleaner, but it actually reacts and removes the anodize from the aluminum. The final part of the chemical process is dipping the parts in the nitric acid. That actually neutralizes what's happening from the etch, and then a couple more rinses, and then we have nice clean parts to go to the die pen line. We're going to dip all those parts in the solution and let them dwell. And while this is happening, if there's a crack, the penetrant will actually get into that crack. After they dwell for a while, we're going to rinse the parts off and then let them dry. And then under the black light inside the curtain, we're going to be inspecting the part. And if we see any of this green stuff coming back out, it's going to be nice and purple under the black light to show us that we have a crack and possible problem. In the event we find a crack, it's scrap and needs to be replaced. From there, we take the blades into the grinding room and reprofile the leading edge, cleaning out all the pitting. And this is where really all of the art is going to happen with overhaul and repair of a propeller. We'll start out with some discs for cleaning the pitting out of the face side of the blade. And we're going to also use some files that take curls off and file the leading edge to reprofile it and get it back to the shape that it should be in. Once that's completed, we will use a wheel on this grinder, and it spins about 3,000 RPM. It's 180 grit compound. And then we start polishing the blade out to make it nice and smooth, remove all of our file marks and our disc marks, and just make it real nice and smooth. And then from here, we'll check the balance of the blades. Once we have all of our blade work completed, we have to bring the blades out and make sure that they will actually balance as a set. And this is what we call a single blade balancer. Place the blade on here, we're going to set up our weights on the other side to have this blade just set nice and level. It's just like using a general scale. And once we have that, now we have this set up for the single blade, and we know that that's going to stay level. So what we'll do is we'll take this off and get the next blade. And what's going to happen is if this is heavy, the blade's going to drop down. If it's light, the blade's going to rise. And in this case, this is actually heavier. And what we would do is actually set this up to the heavier blade, put the light blade back on, and then check to see if we can use lead wool to balance it to the set. If they're not close enough, then we have to remove material from the heavy blade until we can actually balance it by packing lead wool in the balance hole of the blade. And that's actually in the back end. We'll pack lead up in that hole to get all of these blades in the set to set nice and horizontal. Then we can move on to the next step. Okay, now we've done all the rework on the blade. That was too heavy. So then we bring it out and we're going to check it again. And there we have it. We have balance between our two blades in the set. And that's what we need to achieve. In this case, we don't even need to pack lead wool in the balance hole. We're just ready to roll. Now that all of our blade work is finished, we know that the blades will balance. It's time to dimensionally inspect it to make sure that it still meets the manufacturer's specifications. The method of doing that is holding it in a blade fixture, marking all of our blade stations, using calipers and squares to measure the width and the thickness of the blade, a height gauge for checking the face alignment, and a protractor for checking the blade angles. Now a blade like this, it's going to take about a half an hour for a person to measure. And if you have 3 blades in the set, that's an hour and a half of time measuring. 3 people can actually measure this blade and have 3 different answers. Now we have a high-tech method of measuring blades, which Chris has got going on here. And you can see on the computer screen, all of the blade specs for this particular blade design are in the system. When he scans the blade, that's taking a digital image of that airfoil section and immediately reporting the width, the thickness, the blade angle, face alignment, edge alignment, and recording it to the computer. If the specs are good, they turn green. If they're not good, they turn red, and we have to do something about that. Now this machine was actually custom designed about 10 years ago for the propeller industry, and right now there's only about 20 machines in the world. And we have one right here. And this definitely saves a lot of time. This blade that took 30 minutes to measure now takes about 5 minutes. 3 different people can measure it and have the same numbers. The one piece of equipment that we do have here was actually made in the early 40s, and it's a blade twisting machine. And its sole purpose was to twist propeller blades for the military aircraft, and they would change blades out in the field, and they need to make sure that the twist of the blade was proper. Occasionally, somebody might want to change their prop from a climb to a cruise pitch. So on a fixed pitch prop, we can actually re-pitch it more towards a climb pitch or even a cruise pitch. And it really depends on what the owner would like to do with his aircraft. So once it's clamped in, this front ram will actually do the work and twist the blade. The blade that's sticking out the back is staying stationary. The alternative method to instead of using this 60-year-old piece of equipment is the old kink bar. And you just clamp the blade in some sort of a vise, and then this is actually hooked around the blade, and then it's all muscle. I mean, we have this piece of equipment, and I know there's 2 or 3 other ones out there, but I'm not sure if anybody's actually using it besides us. Of course, in the meantime, we have probably a different technician that's actually taking all the hub parts through its process. Along with the die pen inspection, which is for all the aluminum parts, we now have to do the MagnaFlux inspection for all the steel parts. We're going to move all these in here, and they'll be magnetized in the head shot and then also in the coil. So it's actually 2 different inspections to check the part to make sure that they don't have any cracks in them. And as you can see, it actually has a crack in it, and it's really visible underneath the black light. One of the special processes that we do on many of the Hartzell blades is to shot peen the airfoil surface. And then that's what happens in this cabinet. It's an airfoil shot peen cabinet. This rack of guns will move up and down to cover the entire section of the airfoil that requires the peening process. And what's happening is actually compressing the surface layer of the material to make that part of the blade stronger. And there's very few shops that actually do this process in-house, so not only do we do them for our own customers, some of the other propeller shops send the blades here for us to do that for them. The steel parts will be CAD plated, which protects them from corrosion. Aluminum parts are re-anodized and then also painted. During the overhaul process of propeller governors, it's really kind of the same thing as propellers. The units come in, they'll be cleaned up, stripped of their paint, taken apart, O-rings pitched. During the reassembly, we put in new O-rings, new screws, new bearings, put the pump back together, and then it goes on a test bench. During the calibration process, we'll set up the air sections, the oil pressures, the speed settings, and just get it set up for the aircraft, and each unit will have its own set of specs, depending on the aircraft type and the part number of the governor. As part of one of our customer service items, we have overhauled governors that are just ready to go on the aircraft. So to help reduce downtime, we can send out overhauled governors to our customer. They can swap them out and they send the core back. And then they're still flying, no downtime. We overhaul the governors and prepare them for the next time that they need to be exchanged. We've finished our inspections, everything passes, the hub's been re-anodized, the blades have been re-anodized, they've gone through paint, and now we're ready to start assembly of the propeller. And a technician, sometimes in some cases there will be 2 technicians that are going to reassemble the propellers. That could take as much as 16 hours to reassemble 2 propellers and have them put together properly.
Okay, now in this part of the assembly process, we're here at the assembly bench. And as you see, our prop is through overhaul. I have my hub sealed up, the bulkhead's installed, de-ice boots installed, and I'm getting ready to set my angles. So what we're gonna do is put air on it and we're gonna set the latch. So with the air on it and the blades actuated up into the low position, we're gonna add our stop assembly here for the latch and the feather there. And then take the air off. And now the prop's in a latch position, which is the normal shutdown position for the airplane. Okay, now at this part of the stage, we're gonna do our static balance. And what we're gonna do is just find the center of rotation. So me and Chris will pick it up and put it on the stand. With the blade out like this, we can see which blades are heavy and light. This one's just a tad bit heavy. This one's light. And our final blade here is also heavy. So, with our 2 heavy blades positioned up and our light blade down, we know where to add our static weight. Once I'm finished with my static balance, it's been double checked, and now we're ready to move it back to the flange. Now from here, we'll finish doing all of our safeties, charge the dome with air, wipe the prop down, bag it, box it up, and ship it.
One of our customers is actually located down in Japan, and here's a propeller that we finished up, recrated, and it'll be sent to California, loaded on a shipping container, and headed back to our customer in Japan. We actually have customers all around the world, some propellers going out, and this one happens to be going to England. Now we're going to load the props up so I can go visit one of my customers and deliver them back to them. I do like to do the pickups and deliveries myself because that puts me in front of the customer, and I enjoy visiting with satisfied customers and to see their eyes pop open and say, wow, look at that. It's just a really good feeling.
Being a relatively new aircraft owner, I was learning on what had to be done and when it had to be done. When it came to the propeller, Dave was right. He said, I'll just take it from here. They did all the work. It was done in a minimum amount of time. The plane was down very little. The cost was unbelievably reasonable. And the work that was performed was wonderful.
I've been doing business with Rocky Mountain Propellers more than 28 years, and they have overhauled hundreds of propellers for my company, and we have been totally satisfied with the results of each and every one of the propellers. I hope to do business with Dave for many years to come.
We've been in business for over 20 years, and we've used Rocky Mountain Propellers for all of our service. Well, they're the premier propeller shop in the country. We're just lucky enough to be located on the airport with them. Professional service, excellent quality. I don't have to worry about the product that I'm getting. I know that it's safe. Safety in aviation is our #1 concern, and that's why we use Rocky Mountain Propellers.
Well, it's very satisfying in the end, knowing that we have met or exceeded the manufacturer's recommendations or specifications, and also knowing that we're doing our part in aviation safety. My wife and I, Linda, we do appreciate the efforts that our crew puts in. It's great to be part of a team that takes so much pride in producing a precision product for the aviation industry. I look forward for years to come to be part of this team and continue to take pride in creating a great aviation product. Go ahead. I'm waiting for you to say action.